what is reality capture?
You have something like a lifelike digital representation of our physical world.
We hear these terms LiDAR and SLAM, how they differ and how they complement each other.
The very precise distance and angular measurement of a LiDAR device. And suddenly you have the magic algorithmic capability of as well moving your measurement device around.
Once you get the scanner, what does the workflow look like?
So, you take the device, you switch it on, you have the screen in front of you, you walk through the building until you have really been in every room, and you upload the data to the cloud. The term digital twin is massively misused.
On-the-go scanning, how does that compare with like a static scanning?
The gap is closing very quickly. When we started, we were delivering 1.5 centimeter accuracy. Now we are at 4 to 5 millimeter accuracy.
Parameters that are influencing the willingness to not use reality capture.
And in the beginning, people might have wondered, why it's so helpful, to type a document in Word instead of typing it on a typewriter. But over time, we can't even imagine how stupid and slow and impractical that was. And I think in a few years, people will scratch their head and think, not digitizing a building during construction all the time makes absolutely no sense. How did people even do that a few years ago?
The reality capture scanners, there's a big upfront cost that you have to invest. How would you define the return on investment?
In this episode of Constructing Tomorrow, we have Dr. Felix Reinshagen. He is the co-founder and CEO of NavVis, a reality capture company. Felix is an industry-leading expert in indoor navigation and 3D visualization. NavVis offers wearable and handheld 3D laser scanning systems for capturing detailed data of the built environment and also provides collaborative platform for processing and managing spatial data. In this episode, we discuss what is reality capture, LiDAR and SLAM technology, use cases of reality capture scanners on construction projects, workflow of using these handheld scanners, file types and processing times, accuracy comparisons between the on-the-go scanning and static scanning, high upfront investment and how to measure the return on investment, future of reality capture, and much more.
Hi, Felix. Thanks for being here and welcome to the podcast.
Hey, Zidane. It's a pleasure. I'm looking forward to the conversation.
Yeah, I'm super excited to dive deep into the world of reality capture, but I usually like to spend some time in the beginning to clarify a lot of concepts so that the listeners could follow along in the conversation. So, to kick things off, for those who are new to the concept, what is reality capture and what are some different ways in which you could capture reality?
Yeah. So it is a new term, so to say, even though it is just an evolution of something that has happened already since ages. So the foundation of reality capture, so to say, is taking measurements of the real world, and then the difference between like the measuring that has been done since ancient times in all construction, in like settling disputes between between borders and areas of ground, is that reality capture now is doing this really at scale. That you do not only take geometric measurements, so you don't only measure individual points, but you as well color them. And then if you've got really millions or billions of points at high density measured out and put together, you have something like a lifelike digital representation of our physical world around us in full geometric measured quality, different from a picture, so to say, that gives you as well a live like picture of something. But not every point in a picture that you take with your phone or any video camera is, of course, measured out in 3D. And that's pretty much what it's about. And of course, it has been coming through a pretty wild evolution. And of course, nowadays is as well moving into buildings. That's where NavVis is particularly strong, so that you not only work with drones and satellites for reality capture outdoors, but now you can actually move the technology into buildings. And of course, there's a bazillion use cases around that. I'm pretty sure we will come to that in a second.
Yeah. So you mentioned a couple of good points there. One is indoor mapping, global mapping, coordinates. So when it comes to just mapping in general, we hear these terms LiDAR and SLAM. So give me a breakdown of what these technologies are, how they differ, and how they complement each other when capturing the reality.
Let's perhaps start with LiDAR. So all photography, video or still images, of course, is using the natural electromagnetic waves that are all around us that we call light. And so, you have a lens and then you have a sensor that captures that. And with that, of course, you can colorize, so to say, every pixel on your sensor. And the difference is in LiDAR, you are actively sending out beams of light. Actually, to some extent, it's much more comparable to radar, only that radar is on a different wavelength. And now, so to say, the trick is that you now as well can measure distances and angles precisely, because you are sending, so to say, that beam of light out. You know precisely the angle you are sending that out, and then you can measure, so to say, the time it takes to come back. And with that, you have, so to say, a precise measurement of the point you measured compared to your own position in terms of angle and distance. And all that is now miniaturized in a LiDAR device. So you pretty much have many of these disto beams, and the angular measurement is well integrated in the device. And then usually it's as well rotated so that these beams are shot, so to say, into all different directions. And that, if this is done thousands or 100,000 or even million times per second, which is happening in a LiDAR device, you can actually measure, so to say, million points per second from your own position all around you. And that is, so to say, what LiDAR does. But so far, the problem is you can only measure from a fixed point. You have a mixed point, you know where that point is. You have your LiDAR device, which is from that fixed point looking into all different directions and reconstructing, so to say, the environment as seen from that point, potentially in all directions. Now, what you would, of course, like to do, you would love to move your point of measurement.
Right.
And that's really difficult because if you don't know from which point you are measuring from, all the returns are usually not making any sense. But of course it is difficult, so to say, from as you are moving from one point to the next point, there's an infinite number of points. Determine the new point of measurement. Where is that point? So you see, we have a little bit of a hen and egg problem. If you already have an existing environment, you can use LiDAR to determine the point you are looking from. And if you know the point where you are looking from, then you can actually rebuild your environment. But if you don't have either, then we have a problem. Surprising thing is, there is a way around, and that's an iterative approach called simultaneous localization and mapping. And that is kind of SLAM in short form. So what SLAM actually does is you have a LiDAR device. It can as well be a camera, but let's actually take it from a LiDAR device that looks into all different directions and creates some kind of a first map or 3D reconstruction of the environment as seen from that point. And then as you start moving the SLAM device around, you start, so to say, seeing new parts of the world. And you are using the parts of the world that you did already know to determine the new point of measurement. You use the new point of measurement to extend and correct your model of the world, which again helps you determine more precisely your actual point of position. And you iterate that over and over again, and then suddenly you have a kinetic, a movable measurement system. And that is what SLAM does, so to say. And that is why these two technologies combine so well. You have the very precise distance and angular measurement of a LiDAR device, and suddenly you have the magic algorithmic capability of as well moving your measurement device around. These two technologies combine so incredibly well that they are laying kind of an entirely new foundation for doing reality capture in buildings.
Got it. And you touched on a couple of good points there, specifically with SLAM being so useful indoors in a construction project. So NavVis does help with a lot of indoor mapping, essentially preparing a digital twin of the building. I wanted to break down the use cases, and if you can break it down as per phases of construction. So maybe if you could tell me a couple use cases in the design phase or the pre-construction phase, then construction phase, and then post-construction phase.
Yeah. So there are, of course, two fundamentally different types of construction work. One we call greenfield. That is, there's just a green field with no construction. And then, of course, reality capture has less of a play before you start constructing. You might still do a little bit of reality capture, because usually no land is really greenfield. And even if it's greenfield, it might not be perfectly flat. But in general, there is much less use. So the interesting thing is, at least in the Western and developed countries, we do 80 to 85% of our construction work in brownfield environments, because pretty much everywhere where it's interesting to build something, there is already something. And that is where, of course, the first important use case for reality capture comes in. All work that you do in brownfield environments needs good as-built plans, because you are building on something that's already there. So everything that you want to design, every plan that you want to take for how the construction work should be taking place, needs a accurate and complete representation of what's already there. And that's called as-built documentation. Now you would think, all right, why don't you just take the plan that was actually drawn when whatever there is was originally constructed? So the first thing, very often these things are very old and the plans are not even digital and perhaps not even available at all. So first problem. Second problem, usually things were never built as they were documented in the original plans. That's the deviation between like planning and really like implementation that everyone who is in construction knows about. And then third, usually these things have been there for a long time, and usually things change. And very, very rarely are all these changes duly documented in these plans. And that's exactly where reality capture comes in. It allows you in a very short amount of time to get a incredibly accurate and complete as-built documentation. And what you get is a so-called point cloud. And a point cloud is just a bazillion measurements, so dense that it almost looks like a 3D image, is 3D video, so to say, of the building, but it actually every pixel in it really is a 3D measurement. Now the next step is that you are taking these point clouds, this collection of measurements, so to say, and you are creating standardized documentation formats out of that that architects or engineers are used to work with. And that can be both in 2D, like the typical cuts through a building. And then, there are as well workflows for that. You import these point clouds and software tools that allow you to create quickly the drawings in 2D out of the original measurements. Or you even go for a 3D model, a BIM model.
Scan to BIM.
That is then called scan to BIM, exactly. And it has been really established as a standard workflow in pretty much any more complex as-built construction project. That the first thing that you do, you create a BIM model of what's already there. And then that's put into the hand of the structural engineers, civil engineers, architects that start working with that and understand what's already there, what kind of change is going to be possible, where do we need to perhaps tear things down, where can we just make amendments, and as well start the design work. So that's usually where reality capture comes in. Before the construction work even started.
And I would assume after the construction, it kind of ties into again taking the as-builts, right?
Exactly. We'll come to that, so to say, in a second. If you have an existing building, even if you don't want to do big construction work, having a really good and accurate as-built documentation might still be incredibly useful. And now we are actually going back to construction work. Let me, before we go there, perhaps do a very quick detour. Very, very big field that we otherwise not going to be coming back is, of course, if you're an operator of a building. Let's assume you're operating a hospital or a factory or a distribution center in logistics. You will have a lot of additional use cases for a reality capture digital twin, just in optimizing the processes in your building, like in an automotive factory, oil and gas plant, in a hospital. That's already happening a lot. And a lot of use cases out of construction for reality capture are centered around improving, so to say, the operations of a building. But today, of course, we're talking about construction, so that's why I'm only doing a quick detour. Despite, so to say, running a factory or running a hospital, of course, whenever you have good construction work, that's when, of course, you're spending a lot of money in a short amount of time. And there are a lot of additional things that can go wrong, that could go better. And of course, the construction industry is notoriously accused of not being digital enough, of being too expensive, of not making enough progress in terms of labor efficiency, of quality. And of course, one of the biggest drivers in other industries of that has been digitization. So reality capture is like one of the big angles to bring digitization into construction and harvest, so to say, a lot of the benefits of digitization that we have seen in other areas of work over the last decades.
Got it. Now, you actually slightly touched on this, but when it comes to a workflow management, right? So, say if you get handheld scanners or the one that I actually had the opportunity to try the VLX scanners.
Yeah.
And I'm excited to try the MLX. I'm going to a conference next month, so I'll hopefully try that out. But coming back to this, like once you get the scanner, what does the workflow look like? Uh, if you can walk through that and how it integrates into construction workflows.
So that's a great thing about the kinetic scanner, that the workflow is really, really easy. And a scanner, to some extent, is a 3D video camera, if you want. So the workflow is that you set up the scanner, which usually is a little more than just switching it on. The NavVis
Mm-hmm.
scanners have a big display, and
Mm-hmm.
that display does show you, as you are moving, so to say, through the building, how step by step the algorithms put kind of a 3D map of the building together. So you will see step by step as you're moving in your rooms, how the software built this 3D twin, this reconstruction, so to say,
Mm-hmm.
of the building together. You will see every room you have been in, all the furniture, the doors, every
Mm-hmm.
floor, every staircase you have been walking through. So you are holding that device either in front of you for an MLX. There's as well a harness that allows you to rest it on your body, as well have your hands free to open doors, switch on the light, because you really want to go everywhere. That's one of the things. That's like thinking back to the digitizing a sheet of papers. Extremely annoying if you forgot to scan page 5. Because very likely you won't have access to page 5 later. You're just running away with your digital copy. And then later, if you figure you forgot page 5, that might be extremely annoying. So same in reality capture, if you did actually miss a room, very annoying. Because you might need to go physically back to the building to do that room. That's why we are giving you that real-time feedback.
Does it, if you missed out a room, does it match again to the old file? If I just go out there, scan that exact room, and can I just put that point cloud data and match it to the other one?
It's a little bit like, there's of course a little bit of work. That's like, you created a PDF, you did forget page 5, you need to somehow get it into the existing PDF view. So the software already foresees for that. So it's pretty simple, few steps, so to say, in the software to just do that one room and then attach it, so to say, to the data that you already have. Even better, so to say, that even gets more automated. Think a little bit more like AI that would read, oh, this is page number 5 and can automatically sort it in. So that is already even partially there. So for easy cases, it should even be by now fully automated.
And curious to know what is the file type that it generates once you scan the building?
Yeah, so there is a lot of different file types that you can automatically create, and we try to stick with the standard file types. But the basic file type that we are creating at NavVis is LE34, which has established itself as an industry standard for point clouds. But there's as well, for example, something like XYZ and a few other files that that you can automatically export. We're extending that. But the good thing is that I think that LE34 is the open source file format that is more and more establishing itself in the industry. So I think at some point in time, you might even not need all the other formats anymore, because just every piece of software can just read LE34.
Got it.
On top of that, we are saving images. think about Google Street View, so it's not only that you can just like look at it in 2D or in 3D at NavVis, or other reality capture technologies usually go the same way. You can as well look at the 360 images, which is a very lightweight and easy thing, and they are just JPEG. But a format like LE34 as well integrates these panoramic images. So you just have one file that has all the individual point measurements, the point cloud, and the panoramic images all in one file. And that, of course, makes it very easy in handling. And that's what we usually recommend as well people to use. On top of that, you can export the data in different file formats to make it even easier for some specialized software tools.
And what about processing time? How much time does it take if I walk a building? How much time is it going to take to come to a final file?
So perhaps let's round up the workflow. So, you take the device, you switch it on, you have the screen in front of you, you walk through the building until you have really been in every room. There might be one other important step before we come to the processing. That is, you might want to read in so-called control points. Why is that? Because in many buildings, there's already some precisely measured in points, either outside of the building or even in the building, that you can read with the scanner. And that is, so to say, the double check. Whatever mistakes might have happened in the scanning process, if you're reading in these control points, there is like a double check, so to say, of the measurement automatically coming in. And that's, of course, very, very important because, getting these measurements right is very important. And traditionally, this is perhaps the most important part of a classic surveying expert, making sure, that you do a lot of double and triple and quadruple checks so that you hopefully don't have mistakes in your measurement. Because if you have these mistakes, they will propagate into your planning. They will propagate into execution. It might be very late in the construction process that you detect these problems. And then it's usually extremely costly. That's why we recommend that you are as well using some additional control points coming from traditional surveying and measurement instruments, just a few, so that you have always like a double check and you can be 100% sure that your measurements are all correct. So after you've been running through the whole building with your scanner, you connect your scanner either through Wi-Fi, Ethernet to the internet, or you use the SSD card and you upload the data to the cloud. And there all the raw data is being crunched. And you might even have scanned several floors or buildings separately or with several scanners at the same time, to save further time. And all that data can be then in the cloud be processed in parallel. So a good rule of thumb is that it takes around 5 to 10 times the walking time to process the data. So, and that's why as well, usually in scanning, you break the data down in data sets, like think takes in a video. Might be one story each, you have 5 stories, you break it down in 5 data sets, each data set, 1 story, 1 hour. So then it will take between 5 and 10 hours, usually overnight, to crunch all the data. Next morning, you will have it ready. And independent of the amount of data sets, even if you have got 100 data sets, 100 virtual machines, so to say, will be spinning up in the background, all is going to be processed in parallel. Next morning, everything is ready. Then you might still, of course, do a little bit of QA. There's a lot of tools support you in Q&A. And then you want to combine these data sets. There's as well a lot of automated functions by now to combine these data sets to one digital twin, it's more the term, of a building. And of course, we need to be as well realistic. The term digital twin is massively misused. I would even claim there's nothing like a full digital twin of something, because that means you are having a full digital representation of every physical property of a thing, as well updated all the time. That's impossible. That would mean you need to have a sensor, so to say, on every molecule and every atom of a physical thing all the time. There's no technology that can do that. And it doesn't even make any sense. So a digital twin usually represents some aspects of reality of a thing and is only updated so and so often. And what a point cloud, so to say, is a representation of the physical appearance, all the geometry of the building at the point of scanning. which I would argue is a very important part of a digital twin for most humans, because we are visual beings, and the vast majority of the information that we digest is visual. So like the representation of a building then comes out of a high density scanning process. It's gonna be pretty similar to what you would be seeing and perceiving if you're physically in that building. But of course, it doesn't give you all the material properties.
Right.
It doesn't tell you if there is like a piece of metal 10 centimeters in the wall, because that's something that the scanner will not have seen. So it's just like making, because there's a lot of like people like to accuse themselves. Everyone claims they are a digital twin, and then everyone usually answers, "Oh no, you're not a digital twin. We are a digital twin," which I find pretty hilarious, because no one has a digital twin.
Right.
Everyone just has or provides different slices of reality, and hopefully at some point we will have like a internet of digital twins, which give us then many properties of a physical asset that combined give us a pretty holistic picture. But we will, for the next years at least, stay very far away from having every physical property of that thing duly represented.
Yeah, and you also emphasized a lot on the importance of having these points being mapped accurately, as it might have impacts future on if it's not done correctly. So talking about accuracy, uh, obviously your SLAM technology is an on-the-go scanning. So how does that compare with like a static scanning?
Yeah, so many in the construction industry might have been moving from point measurements like total stations or tape measurements to static LiDAR, so often called terrestrial laser scanning. And of course, that has been coming through a huge evolution. And today, from one point, of course, you can make fantastically precise and detailed measurements. But of course, it takes some time, because then you do one scan from one point and you only see what's visible from that point. So if you put yourself in the middle of a room and then you think, can I see everything in that room from that one point? Of course, it's an empty room with with a very simple geometry, it might be possible. But if there is anything in the room, a table or some stuff, or it's a little bit more complex room, of course, you can't see everything in that room from that one point of scanning. You will actually need to move yourself or the scanner to several points in that room to get a occlusion-free or like complete picture. And the more complex the rooms, think about pipes, technical rooms where construction work's going on, there's machinery and stuff, then you will need a huge amount of individual scans from individual points. So now we come to the quality. So still the highest possible quality, and we talk about millimeter, like 1 millimeter accuracy, perhaps 2 or 3, that you can actually take from one point of measurement. As you are now combining your individual points of measurement, you will get some error into your system. That's like putting a puzzle together, so to say, of many individual scans. And there you, of course, have some error propagation. So with a dynamic scanner like NavVis, you will now get 4 or 5 millimeters accuracy. So you are not at the 1 to 3 millimeters that you can get from a static scanner, but that's only from one static scan. So as you're combining static
The error
scans,
increases.
you will as well have some error propagation. Usually you will even have a more complete picture with a dynamic scan, because no one can actually put a static scanner into as many positions as you will automatically put a dynamic scanner, because a dynamic scanner scans from an infinite amount of positions along the path of travel. So you will have a much more complete scan. So in terms of a kinetic scanner or SLAM scanner gives you always a more complete picture, as well as a more realistic colorization, and so there will be attributes of data quality that are definitely significantly better in a dynamic scanner. It's going to be a fraction of the cost. You would actually think, why is outdoor scanning so cheap? You need to build a satellite, you need a rocket to get the satellite into space, so it should be ridiculously expensive. But it's actually outdoor square meters of scanning are being mass produced. You build one satellite, and then after that, there's almost no labor cost included. That's like building like a perfect machine that you build once and pay for once, and then it builds like a million pieces. And each of these pieces costs almost nothing. even though the machine was expensive. And indoor scanning used to be exactly the opposite. The machines to do that were vastly less expensive than a satellite. But unfortunately, they were very slow in production, and you still need a lot of manual work. And that is what's happening now. SLAM scanners actually are machines that help to go into mass production of indoor scanning or mass production of reality capture by distributing the same amount of work onto now many, many, many more square meters. And by that, so to say, driving down the production cost of an individual square meter. And right now, you will still have a certain trade-off in the local accuracy of a scan, but the gap is closing very quickly. When we started, we were delivering 1.5 centimeter accuracy. Now we are at 4 to 5 millimeter accuracy. So the gap is closing quickly. I would even argue for most jobs on the construction site, a kinetic scanner is going to be delivering you better quality because it is first data that you will have compared to data that you won't have because it's affordable. Second, it's going to be very complete data compared to terrestrial scans where this is hard to do. It's going to be very fast data. You can actually work in incredibly fast turnovers. And last but not least, it is usually much more accessible data because kinetic scanners usually deliver data in data formats and software tools that are very, very easy to use, like fields like Google Maps. Yes, there are some use cases left. I'd argue very few, where the difference between 4 millimeter and perhaps 1 or 2 millimeter really matters. For the majority of use cases, I'd argue that the best kinetic scanners like the NavVis VLX already deliver more quality, so to say, that you can actually practically make use of. And it's going to be delivering that in a very realistic appearance and in a very complete and holistic way. So, but give us another few years, and then I think the gap, so to say, to terrestrial scanners will be closing even more.
And you kind of touched on the cost. So obviously with the reality capture scanners, there's a big upfront cost that you have to invest. So how would you define the return on investment? What's the metric here that the stakeholders need to consider when investing in these technologies?
Yeah, I think the first and most important thing to understand is that a kinetic scanner these days is not any more expensive than a terrestrial static scanner anymore. That used to be the case, but that's absolutely not the case anymore. But it's still a significant upfront investment. So give you an order of magnitude, the NavVis MLX that we released, still like a 35,000 euro, 39,000 US dollar upfront investment. So how is this actually being returned? And of course, you still need an operator. And then, of course, you can actually first compare that to static scan that you might have already made before. And there, the case is just very, very simple. With the same capital investment and the same amount of labor, you can now do 5-10 times as much scanning. Which means if you allocate the very same cost now on 5 times more square meters, the unit cost per square meter is just 1/5. A very, very simple math, so to say. If you do even more, if you go to 10 times more scanning, which many of our customers do, you're at 10% of the cost that you used to have. Now let's go even further. Classic surveying is a really difficult craft, and you need now people that have studied that and are total experts for every part of that process. Dynamic scanner with the newest generation of scanners still requires surveying know-how on the background to understand what data quality you need to do, like the supervision, quality assurance. But most of the steps you can actually now do with someone that you can actually train in 1 or 2 days. So on top of distributing the same amount of labor on 10 times more square meters, for the vast amount of labor, you might now be able to use labor that just costs you 10-20% per hour. So that might even give you another almost full order of magnitude of cost savings. And then, of course, you can look at it from both angles. So return on investment, very, very simple usually. You look at all the work that you would have done measuring anyway, and now you can just do it with a fraction of the cost. So you can actually recover your capital investments even in a fraction of the time. But now it goes the other way around, like almost ever with mass production. If you can produce something that cheaply, suddenly a bazillion new use cases are coming up. I'm always making the comparison. When I started my career as a consultant, I got a BlackBerry. I was just like in my early 20s, and this was just the coolest thing. No one else had a BlackBerry. And the reason was not that the BlackBerry was so expensive, the data plan was so expensive. It only included a few megabytes and it cost a few €100 per month. And it was just enough megabytes so that you could actually do calendar and email synchronization. And of course, logically, very few people use the BlackBerry. Nowadays, of course, a megabyte of data roaming costs nothing. We are measuring that in gigabyte, so a factor of thousands, 3 orders of magnitude in between. And now every kid sits in the subway and watches TikTok videos, And so it's not only that the use cases that, to drive the adoption of the BlackBerry, which was calendar and email and messages, of course, is now possible at a fraction of the cost. It's all the mobile internet, everything that wasn't even imaginable because the cost has originally been prohibitive, that as well came to life by driving that cost down. I think that is something we are just experiencing now with reality capture, that by giving our customers the capability of creating so detailed, accurate, and easy to use and low cost digital representations of the buildings, suddenly it makes sense, to use this kind of data for all kind of use cases where it was prohibitively expensive before.
Yeah, I think the just to summarize, I think the key takeaways for me was having mass production, huge batches of capture scanning. There's avoided cost in avoided reworks. There's documentation, saving cost on any future potential litigations because of improper documentation. Transparency. I mean, this is just we came up with this in a 5 minute segment, but would that summary sound accurate? Would you like to add anything else in this?
No, I think we've been going through most of the categories, even though sometimes high level, they don't even sound that impressive. It's a little bit like, how impressive is it that you can now send in a text, to someone around the world in seconds instead of days or weeks? Is this really worth that much? Obviously, it's worth a lot, because we are doing nothing else anymore. And how important is it, that you don't need to go in an archive and actually crawl through huge numbers of documents that have you physically stored there? So think about the whole value chain of everything that you suddenly can do once you have something digitized, in terms of looking at it from everywhere around the world, searching it, simulating it, running AI through it. AI is running on data, but only if it's digital. So suddenly you can actually give AI access to that building and start doing its magic. So all these additional levers of value are becoming unlocked by scanning and digitizing a building. And I think we are only just right now seeing the tip of the iceberg. And in the beginning, people might have wondered, why it's so helpful, to type a document in Word instead of typing it on a typewriter. But over time, we can't even imagine how stupid and slow and impractical that was. And I think in a few years, people will scratch their head and think, not digitizing a building during construction all the time makes absolutely no sense. How did people even do that a few years ago? How were they spotting mistakes? How were they actually getting consulting work in? How did they actually do distributed modern work? How did they, use digital consultants? I think that's going to be just the standard on every construction site, and we'll see vast benefits in terms of cost overrun, additional productivity improvements, better distribution of work, getting better expert opinions, having less kind of litigation and fighting on construction sites. Just in general, much more transparency, benchmarking, best practice sharing. So all kind of these things that have had a hard time getting onto construction sites will need this as a foundation to work.
Yeah, so keeping the cost aspect aside, you've obviously seen a lot of companies adopting it and also resisting it. What are some of your observations? that you've seen in parameters that are influencing their willingness to not use reality capture?
I think the biggest, it's very similar to resisting any type of new technology. It's to some extent always painful for human beings to change. And reality capture just changes many things. We are detaching a lot of the work from the physical thing. But of course, you have to as well put in some work. And it's many small things usually, that kind of hurt on the way to adoption. So how do you best time reality capture on a construction site? Um, how do you make sure that you quality check the data? Sometimes people make some mistakes, and then the data isn't fully usable, and then they are disappointed. So all these little things, these little learnings on the way have to be made. There's always mistakes happening on the way. Like, just think about all the PC crashings that we had in the 90s, how disappointing that was. And you might have just written five pages in Word, and then it crashed and was all gone. You think, oh, fuck, I'm kind of going back to the typewriter. But of course, the world didn't go back to the typewriter. It's just like we learned to implement autosave and, bazillion other little things. And we are going through that process right now. And of course, it's general digital know-how. It is the adoption of like all the other tools and skills on the way to make really use of that data. If you don't have that, then of course the data itself is much less useful. So it's a very typical technology adoption problem that you pretty much have with every new technology. There's a lot of little learnings that you need to collect on the way. There's a lot of mistakes that you will naturally make on the way, and that will lead to some initial disappointments. And as always, there are some people that will like iterate and overcome this, and they will actually gain a huge advantage. Like, the companies that learned how to use email and PCs and video conferencing early, of course, naturally had a huge advantage. And I would say at some point in time, you can't even survive anymore. That's going to be taking some time until we be getting to that point. But with a new technology that delivers that far-reaching and fundamental advantages, it is very clear to me that at some point in time, if you don't adopt it, you're going to be out of business. You're never going to be matching the kind of quality improvements, speed improvements, learning improvements, style of work improvements that companies that have really adopted this well will be having over you.
Yeah, and I think in the last few years, most of the construction companies are leaning towards digitizing their workflows. You started NavVis in 2013, if I'm not mistaken, and it's almost been a decade now. I'm curious to know what has been the journey like what changes have you seen? What has been your learnings so far in this 10, 11 years?
Yeah. So I would always a little bit take out the first few years, because we were not really working with the market. It was still a lot of R&D and fundamental product development. So it was, I think, perhaps 2016, 17 that we really were out there in the market. And so, of course, we were at a very different still place. It's enormous, how even these 6 years have actually changed the world in terms of digitization. So naturally, we were much more limited to people that were even further ahead, so to say, of their time. And that was very much like forcing us to focus on areas where people were already using reality capture at a significant amount before. Because that is where we could generate the biggest savings. If people were already spending a huge amount of reality capture, then the significant mass production effect, so to say, now you can actually produce the same amount of square meters, but with much less labor and with much less overall cost. We're actually coming to work and delivering the biggest advantage there. So this was like really large and sophisticated surveying and measurement companies that mainly focused their work on doing reality capture already, like with other tools back in the days. And then a lot of owner operator problems, mainly in production. You have got huge factories with enormously expensive machinery and stuff with a lot of change. And we did a lot of work in the beginning, like to improve our technology in the automotive industry, where you have exactly that. And that were, so to say, the early areas. It's a little bit like the BlackBerry, before everyone started to use email and calendar and text on their phone, they found a niche, certain group of business people, managers, so to say, that needed this technology a lot. And we're already trying to find some other ways around where this technology could land. And we were, so to say, finding our pocket, so to say, where the need for this kind of data and cost savings in creating it were most pressing. And then I think a big breakthrough year for us was 2020, the COVID year. Because suddenly it became so obvious for many people that digital access to a physical place is really valuable if suddenly you can't physically go to that place anymore. So that was really a breakthrough year for two reasons. It was the COVID year, and we made a change. Our first scanners were still cards. So we thought about, like, let's make a small version of the Google car that drives around, and as well with the cameras and LiDAR devices, and put that all in a cart. But that was still very limited. Like, think about trying to move a cart around on a construction site. That can be pretty tedious. And in 2020, we released our VLX wearable scanner that's shoulder carried, and you can move around in a building on a construction site so much more easily. So the combination of these two events was really a breakthrough. And then from there, we saw actually faster and faster adoption year over year. As well, like people opened up to cloud much more bandwidth, in general, like a big step up of digital proficiency after COVID. Everyone's lives became just much more digital. And I think we were perfectly tying into that trend.
Got it. Also curious to understand, so you obviously cater to a lot of different countries and continents. What are some of the consumer behaviors or patterns that you've seen?
Yeah. I think perhaps one of the most important insights is that this worked best and at first in countries with high labor cost. Logically, if labor is very, very cheap, the prospect of saving labor cost is much less, so to say, compared to countries with very high labor cost. And usually as well, high labor cost as well correlates with countries with a very sophisticated economy already, with much higher digital adoption, with much, much higher construction cost, higher litigation costs. So not only did the cost savings matter a lot more in these countries, but as well, people were like more digital, literate, so to say, and had an easier time adopting than in other countries. So that's why, of course, in Northern Central Europe, United States, and then like countries like Japan or like the most developed kind of Asian cities, now Middle East, so to say, we see the strongest adoption. And then from there, of course, now we saw like a broadening, and as well, like in perhaps countries with less labor cost. Usually this is adopted first in the most sophisticated, complex construction or production environments. But of course, there to the point that's perhaps, already happened in adoption in some very high labor cost, like very high GDP per capita countries. But I think a good way we see the global distribution is around labor cost and general sophistication in production and GDP per capita in general.
Got it. And I would like to close this out with the last question, which is, what do you see as the future of reality capture next 5 to 10 years?
So I think reality capture is going to be ubiquitous. And at NavVis, we have set ourselves the mission of bringing NavVis into every building. And of course, that's still a long way to go. But the fundamental belief is behind that everything that's around us, every physical thing, will have a digital life and a digital presentation as well. And reality capture is, of course, one of the fundamental ways of making physical things digital and synchronizing our physical environment with our digital representations, our digital twins of that. And buildings and everything in there. It's like the most valuable assets in the world. It's trillions and trillions, so to say, of value that has not really found a full, like, sophisticated, regular way of being made digital. And I think reality capture is going to be filling a huge gap there, as our lives become more digital, or workflows, all kind of value creation, will become more digital step by step. And I think reality capture, pretty much everything around us will play a huge role in there. And we hope, we can foster that and do our part in that big transition that we will, I'm absolutely sure, over the next years.
Before I let you go, I want to do like a quick rapid fire with you. So my first question to you is, what's the biggest myth about reality capture?
That it is complicated and expensive.
Okay, I got a spicy one for you. Speed versus accuracy, if you have to pick one.
I think we have the accuracy that you need, so now speed really is it.
Okay, what's one favorite tech gadget that you like to use apart from NavVis?
I'm a huge fan, of course, of my phone. I couldn't live with it anymore, but as well, with the last years, my Apple Watch actually has become a really integral part of my life, specifically all the monitoring, like, of my physical activities that I really enjoy. Like creating the digital twin of my body, so to say,
Yeah.
as we are creating
Yeah.
a digital twin of the building. There's just a lot of benefits in that.
Yeah. What's your go-to productivity hack?
I think there's not one. It's actually continuous improvement. You have to review your own habits and your ways of dealing all the time. There's always a next step. There's never this one thing you have achieved and then you are productive. It's constant work, unfortunately. That's, by the way, the best book to read on productivity is Atomic Habits. So it's all these little things that add up. It's not the one big thing, unfortunately.
Yeah. And the last one I have is, what's the one best advice that you've received in your entrepreneurship journey and that you would like to pass on to future generations?
It's all about people. Great team that's really motivated will always win. And always go for the right people first. I think that's the one thing. Never compromise on the people side. Only work with the people that are capable and trustworthy. That's kind of the whole that's the whole magic. And the content and the way to solve the problem is going to be a new one every day. And there's going to be a lot of unsolved puzzles in front of you in the future that you can't know about at the moment of founding or every moment on the journey. If you've got the right people around you, you have the highest probability of getting through it.
Yep. Awesome. Felix, thank you so much for doing this. I really appreciate it. I think I personally learned a lot from this episode, and I hope the listeners could learn a thing or two from it as well.
Sinan, it was such a pleasure. Thanks for inviting me. Thanks for your questions. It was a great pleasure for me and a fun discussion. And I'm really curious to hear the recording of the podcast at the end. And I hope that our listeners will enjoy as much as we did during the discussion today.
Thank you for tuning in to Constructing Tomorrow. I hope this episode provided valuable insights and tips. Don't forget to like, share, subscribe, and drop a review or a comment. Until next time, keep building and stay curious.